Assalamualaikum and hi. My name is NAJIHA binti Muhammad Noor. I am a final year student from School of Computer Science, University Science Malaysia. In this video, I would like to talk about my final year project, which titled E-bike or e-scooter collisions avoidance system. Electric bicycle, also known as an e-bike, is a bicycle with an integrated electric motor used to assist propulsion, while e-scooter is a motorized scooter which powered stand-up scooter with 2 or 3 wheels using a small utility internal combustion engine, or more commonly an electric motor. This system is aimed to reduce the risk of fatality or serious injury for the e-bikes or e-scooter riders. This proposed project uses a LIDAR sensor to detect high-speed distance to avoid possible collisions from happening. In this project, Raspberry Pi 4 Model B board, the F Mini Micro LIDAR module sensor, and buzzer I used to build the system effectively. The problem statement for this project is some of e-bike or e-scooter do not have high technology sensor monitoring system to measure and detect high speed distance that could help and warn the e-bike or e-scooter rider to prevent the collision from happening. To solve the problem, e-bike or e-scooter collision avoidance system is the solution of the previous problem statement because this system uses LIDAR sensor which can measure and detect distance accurately. Second is, there is also a buzzer that will produce a beep sound to warn the rider if any vehicles come nearby to the e-bike or e-scooter. The next one is, the system has a camera to detect objects. The e-bike or e-scooter collision avoidance system has this following objective. First, the objective is to measure and detect distances between e-bike or e-scooter with nearby vehicles. Second is to warn and alert the rider by beeping the buzzer. Then the last one is the camera is used to capture and detect objects. There are 2 modules in this collision avoidance system, which are distance detection module and object detection module. The distance detection module consists of 2 sub-modules, which are sensor and buzzer. The sensor is to measure high-speed distance, and the buzzer is to warn a rider by producing a beep sound if any vehicles come nearby to the e-bike or e-scooter. For the object detection module, has only one sub-module, which is camera input. The function of this sub-module is to capture and detect objects. This is my system architecture. The system architecture consists of laptop, hardware components, and virtual environment part. All the electronics are attached to the Raspberry Pi and allow the Raspberry Pi to control them. The PuTTY and the VNC viewer are used to run the code and the system in virtual environment. This is how my project design looks like. The picture here shows all the electronic components are attached to the Raspberry Pi board, and then I implemented it under the skateboard deck just to know how it actually works if I implement on the e-bike or e-scooter. And then at the back trunk of the skateboard have 2 components, which are sensor and the camera. The camera is to capture and to detect objects, and the sensor is to measure and detect high speed distance between the e-bike and other vehicles. The system has 2 benefits, which are a low-cost LIDAR system that easy to install on any e-bikes or e-scooters or even on a normal bicycle. Next is, the system will give safe riding to the rider since it will assist and help the rider to detect possible collisions. Next, I will proceed with the project demo. First, I will open the PuTTY and enter the Raspberry Pi.local the device supports MDNS, and then log in as Pi, and then I enter the password. Next, I will proceed to open the VNC viewer. The step is same. I will enter my username and the password, and then now we can see Raspberry Pi desktop shared with the VNC. And then I open the Raspberry Pi terminal and enter the command to run the sensor. Here is the result of the distance detection. And then I will proceed with the camera module. I enter the command to open the camera. And this is the result. It shows the gray and the colored vision. And then proceed the real-time object detection. The camera function to detect the object, and I enter the command yolovideo.py. It takes some time to open and to run the module, and it also takes some time to detect objects. Here is I open the picture just to know if the camera can detect the picture as motorbike or not. As you can see here, the camera can detect the laptop, and then it detects my hand and also the cell phone. And yes, it detects the motorbike. And then I did some scenarios to show how the system actually works. And this is the 5-meter distance. The sensor detects the distance, and the buzzer will produce a beep sound. And then the 10 meters distance, the buzzer is continuously producing the beep sound. And I proceed with the 12 meters distance. More than 12 meters distance, the buzzer does not beep because the sensor can detect as far as 12 meters. And then I tried with the moving vehicles, which I used the motorcycle approaching the skateboard, and the result is the buzzer is beeping. And this is the from other side to show how the system actually works. And then I tried a moving skateboard approaching static object, which the skateboard is moving and approach the object that doesn't move. And then that's all for me. That's it, the demo. Thank you.